Hello everybody. In this video I will be explaining the feedback for your quiz 3.1 B, version B. This video is for that one. I will be going through how to solve the problems, and I'll also explain how this quiz was graded if you're curious. So the first problem that I'm going to be going over is 3.1 at the basic level. And remember, if you get the basic level you should get a 75%, which would be a total of 7.5 points out of 10. So let's just start with solving the problem. In this problem, so if we use our guess method, so we talk about our givens. So our givens in this problem are 5 meters per second, 35 meters per second, and 10 seconds. And determine the acceleration. Acceleration is going to be our unknown, so A equals question mark. That's the U in guess. And then for our givens, we're given 5 meters per second, which sounds like velocity. And it says you go from 5 to 35. So this one would be our V1. 35 meters per second would be our V2. And 10 seconds, that sounds like time. And there we go. We got our givens and our unknowns. The equation, the E in guess, that we're going to use is A equals V1 minus V2, V2 minus V1 over T. And the reason why we want that equation is because we have to look at our givens, V1, V2, and T. That has to be in the equation. And A, acceleration, has to be in the equation as well. So, and we want our equation to say A equals in this situation. And so we know that we have to use this equation here. You have to have this equation on there. And then GUE, the first S is substitute. So now I'm just going to take my givens and substitute them into my equation. So I end up with 35 meters per second minus 5 meters per second divided by T, 10 seconds. And then we simplify. That's our, solve. Sorry. That's our last step. So 35 minus 5 gives me 30 meters per second are the units, divided by 10 seconds. 30 divided by 10 gives me 3 for my number. And then my units would be meters per second squared. Other acceptable ones would be meters per second, or meters per second over seconds would also be acceptable units. And there we have it. There's our final answer. Now our scoring breakdown is going to look like this. We got to get to our 7.5 points. So the way this is going to look is your equation is worth 1 point. So you have to have that equation on there. Then for your work, so your substitute portion, it's going to be worth a total of 3 points. So the numbers are worth 1.5 points. And the units are also worth 1.5 points. So if you did 35 minus 5 divided by 10, that only gets you the 1.5 points. And so your total points for your work would have been 3 points. And then your number for your answer, so getting 3, that's going to be worth 2 points. And then your units for your answer are going to be worth 1.5 points. So in case you're curious, the way the scoring breakdown works is you can miss any one of these pieces and still pass except for your number here. So if you got this equation, you did your work, all correctly, you had meters per second squared, but you said 6 meters per second squared, that would put you at a 5.5 out of 10 if you only got this, which would not be enough to pass. But let's say you didn't use your equation, which is likely, and you did your work correctly with the units, and you got your correct number and answer, you would only get a 6.5 out of 10 if you only got the basic level correct. And so you'd still pass. If you missed 2 things, like you did meters per second and for your answer and did not have units in your equation, that would not give you enough points to pass the basic level. So that's that. All right, so here we got our meets level. So again, we're going to go through a guess method here. I'm given this information here. I'm given this. I'm given this. So we got our acceleration. We've got the marble started moving at this speed, so that would be v1, and ended up moving this fast, so that would be v2. How much time? That's what we're going to solve for. That's be our unknown, t equals question mark. All right, and then we got to figure out our equation. So we start with this equation, a equals v2 minus v1 over t, because all the pieces are in here. However, it doesn't say t equals yet. So the way you get that is by multiplying both sides by t. These t's go away. I'm left with t times a equals v2 minus v1. And then we want to solve this for t. So again, so you got to divide both sides by a. The a's go away. I'm left with t equals v2 minus v1 over a. This would be our equation. A lot of you just started here because you just memorized that equation. That's fine. You still need to know how to do the algebra, but if you just started here, that's also okay. That's our equation. And then we need to substitute and then solve. So I got my t equals my v2, which we said was 3.4 meters per second, minus v1, which I said was 15 meters per second. It's an S, I promise. Divided by my acceleration, which is negative 2.4 meters per second squared. Now that negative is going to be important, and you'll see why in the next step. Then we have to solve. So 3.4 minus 15 is negative 11.6 meters per second. Divide that by my negative 2.4 meters per second squared. And then if I do negative 11.6 divided by negative 2.4, I get a positive value, which is important, 4.8 is what the number I get. And then the units, we end up with meters per second divided by meters per second, and then we just have 1 second left over. So what that looks like is we have like 1 over seconds. And this is just a little sidebar, but if you care, you're doing 1 divided by 1 over seconds. And dividing is the same thing as multiplying by the reciprocal. So the reciprocal of 1 over seconds is just seconds. So you have 1 times seconds. So in the end, we end up with seconds here for your answer. And again, I'm going to break this down, and I'll use a different color for that. So the meets level, if you get the basic level and the meets level, you're supposed to get like a 90%. So that'd be a 1.5 points total. So we're going to have to score things just a little bit differently. So the way this is going to work is for your work, that's going to be worth half a point. I know before it was worth 3 points, but this is the way it's going to work out. And you must have units and numbers, or I should say must have correct units and numbers in order to get that half a point. So if you just did 3.4 minus 15 divided by negative 2.4, no units, you would not get this half a point. In the other one, you got points for both, but we don't have the points to work with on that one. And then here, that's going to be worth, so having 4.8 would be half a point, and just having seconds would also be worth half a point. Okay, so that's all well and good, but I still think that this equation is important here. So the way that's going to work out is if the equation is missing, you get minus 0.5 points. Okay, so let's say you had just written down seconds. You did not have the equation, you didn't have the work, you didn't have 4.8, you just wrote seconds on there. It seems like you'd get half a point. Well, But if you don't have the equation, you're not going to get that half a point. Or more likely, if you had all your work and everything all correct, everything's correct, but you're missing your equation, you'd only end up with 1 point. You couldn't get negative points though. So if you left it blank, I'm not going to give you a negative point on that. So that's number 2. All right, and then we've got our extends level. Now this one is going to be worth 1 point. And what I'm going to do, since I have to be done in 15 minutes, so I've only got really 4 minutes left to do this one. So what I'm going to do is I'm going to pause the video, pause recording. I'm going to show all my work, and then I'll resume the video and I'll explain how to solve this problem. But I won't be with you every step of the way. But I'll explain everything. I'll see you in a moment. Okay, I'm back. The one thing I will tell you before showing you all my work is how to kind of approach this problem. So there are 2 hints that I gave you and some useful information. So first, you're going to go at a constant velocity for the first 0.25 seconds. So we're going to use our constant velocity equation, which is v equals d over t, to solve for distance. And then we're going to use this piece right here for our accelerated motion portion to figure out how far you're going to travel in that time. Now, the reason why we're solving for distance for both portions is because we need to figure out if we're going to hit the deer, which is 180 feet away. So by the end of the problem, we need to know if our distance is greater than or less than 180 feet. Okay, I'll be back. All right, and here we have it. So for part 1, like I said, you're going to be moving at a constant velocity for those first 0.25 seconds. So it means you're going to travel some distance. So I used v equals d over t, rearrange that for distance, and we end up with, our 95 feet per second times 0.25 seconds. You'll travel 23.75 feet in that first moment while you're putting your foot getting your foot to the brake. You're going to travel 23 feet. All right, and then we got our second part, which is when your foot is now on the brake, your car is now slowing down, and we want distance and acceleration. So we want this equation here, d equals v1 times t plus 1/2 at squared. But that's all well and good, but we still need the time. So what we have to do is use this familiar equation here, v2 minus v1 over a, substitute in, and we find out that, hey, it's going to be 4.32 seconds for you to slow down and stop. Then we're going to use that equation with our first equation that we talked about, and then we're going to substitute in that time that we found in that original equation. Here's my work. Pause it if you need to look at it. But what we end up getting is 204 feet. So you will travel 204 feet before you'll actually slow down and stop. So then you take your first part, your 23 feet, and add that to your 204 feet, and you end up with a total distance of 229 feet. Is how long you're going to travel before you come to a complete stop. And you compare that to your original distance that we're trying to compare to. The deer's 180 feet away. You're going to smack that thing and probably blow it to pieces because you're going to travel 229 feet and the deer's only 180 feet away. So yeah, you're going to hit the deer. Now in this one, there were only a few people that actually got this question correct. But there were some people that maybe got the second part, but maybe not the first part. So in that case, you might get half a point, but nearly everybody either got it or did not get their full point for this extends level question. And it looks like I finished a whole minute early. That's all I got. Thanks for listening.